Hello, everyone. So as you probably see, the title is agnostic on the constant, and that's quite interesting what we have with a Lakehouse paradigm and how the Lakehouse is actually changing the whole analytics and AI data space. And I'm very glad to have that opportunity to talk about this topic at Open Source Analytics Conference. And I will say we'll just dive in directly in my slides. Well, I want to start with open source, right? So, guys, everyone is here because we have that great thing as open source, and what I want to motivate everyone who is watching that presentation to be a contributor to open source. And doesn't mean you need to write a code. If you can't write a code, you don't need to go and write directly code. What you can do, you can just go and make a review, write documentation, just check if everything works as expected, etc., etc. A lot of stuff what you can contribute to open source. So please take a chance and become an open source contributor, and that will help us to grow the community. It will help us to drive the innovation, because to be honest, if you look at the last 10 or 15, 20 years, you will see that the open source was the main innovation driver in the IT sector. So if you look at the Kubernetes microservices architectures, if you look at the data, you will find Hadoop and you will find Apache Iceberg and all the different standards. Everything is about the open source. So use your chance, become the open source contributor. A quick introduction. My name is Viktor. I'm co-founder of a company named Vacamo. And if you will have any questions later on, just reach out to me. It's victor@vacamo.com. Go to LinkedIn, ask your question. I'm happy to chat. I'm happy to chat especially about the data topic and what we can do with the data. And well, I mentioned open source, and we at Vacamo, we love open source as well. It's why we started the open source Apache Iceberg REST catalog named Lakekeeper. And you can go to our GitHub, Lakekeeper/Lakekeeper, check it out, play around. There's a folder examples. It's super easy just to go and create a complete demo environment with Lakekeeper and everything what you need just to see how a lakehouse, enterprise-ready lakehouse, can be actually established with a simple Docker Compose or Helm chart. And that is not a lock-in, but it is very agnostic and neutral what you can do with that stuff. Before diving into the topic itself, let's just understand how we actually got to this situation. So what happened before a lakehouse? And some of you probably know and maybe read in historical books about the data warehouse, and it doesn't matter like if you look from Oracle perspective, Teradata perspective, or Postgres perspective. So 80s, 90s, where we started data warehouse. We could store our well-designed data in a third normal form, and we could store that in a star schema, snowflake schemas, and then we could analyze the data. Around 2000, internet happened, and what we've got some kind of a solution to store this semi-structured and unstructured data in some sort of a big data system like Hadoop, Spark, Hive Metastore, and we were able actually to analyze terabytes of data, 10 and hundreds of terabytes of data. It was possible to go and then read CSV files, JSON files, Avro files, and then later Parquet and ORC. The cloud happened in 2010. Around 2010, we got the cloud, and we got the new innovation move on the cloud data warehouse. And the main players are here probably Snowflake and Redshift. And the good part and the true innovation on the Snowflake and Redshift was that they could separate storage and compute. And in that situation, we could actually analyze a lot of data. We could store data independently from compute, and that was a very cool innovation from that period of time. So same innovation happened on the data lake, 2020. Databricks is the main player here. Databricks allowed or built a fully managed platform that could be used to analyze petabytes of data. And it was quite cool, but we still lived in two different paradigms. On one end, cloud data warehouse, where we have a transaction schema evolution. On the other hand, we had like no of that mechanism. We had no transaction. We couldn't just go and delete data because Parquet is immutable. But we could analyze really like petabytes of data. So the idea came around, so why not actually to get those two different systems in one to allow you to have a same feeling what you know from a database, but not having a database, and store a simple per key files in your object storage, but still have the SQL transaction semantics, so you can just go and make your select, insert, update, delete. And that's how we got actually to the Lakehouse. And the main player is here Apache Iceberg. You probably heard about Delta tables, you heard about Hoodie, and there are newcomers on the open table formats, but today Iceberg is probably the most front runner of the Lakehouse. So Lakehouse architecture, what it is, it's quite simple. What you know from a data warehouse, you have producers and consumers, and what they need to go and store the data on a storage, which is a simple object storage. It can be like Amazon S3, it can be a Pure Storage Dell, it can be Google, Azure, it can be NetApp. So you can just go and store the data. You still have write and read compute, and what you need additional is Iceberg catalog. And that is already the agnostic architecture for you, where you can actually go and replace every component. So you don't have like a lock into a single vertical stack. So if you want, you can have like a Spark on write and you can Trine on read, or you can just go and replace and have ClickHouse on read, and you can have Iceberg on write. It's super easy from that perspective, just to play around and take the best technology what you need for your use case. But let's just simplify the whole stuff, and then you will see that you have only three main components: storage, where you're going to store your per key file; Iceberg catalog, that will manage the meta information of your Apache Iceberg table; and compute. And that's it, what you need to think about if you build a Lakehouse, a modern architecture for your analytics. And it's super easy, again, to keep that part agnostic and neutral, so you don't have a lock-in. And the good part is that you can start absolutely from the open source stack. So you will take, let's say, Ceph or Minayo on storage. You can take Lakekeeper Polaris on catalog, and you can take, I don't know, Iceberg, Iceberg and ClickHouse to have your compute. And then you can go and replace them as you need it, and you can scale them as you need it. The interesting part is about the catalog, because it's quite new stuff, and it's confusing, because if I talk to users and customers and they tell me like, oh, we have already catalog, we have a data hub, we have Alation Calibra, but that's not the same catalog what we have actually in Iceberg and in Lakehouse. Well, this is a picture of Iceberg. So at the top, you have a catalog, what has, at the beginning at least, the only one thing to point to a metadata JSON file, which is the collection of the current information. If you want to read the Iceberg table, where you will run your select statement, you will just go to the metadata JSON file, and that file will actually tell your query engine which per key file you need to read to get the current state of your table. And that's how we began in 2017 with Apache Iceberg. We got a lot of different catalogs, and that's the era what we call before REST specification, because every catalog brought its own specification how to communicate to that catalog. In 2022, we got actually more and broader competency on the catalog. First of all, we got the REST specification for the catalog, and that helped the adoption of Iceberg. So right now, like every client, it doesn't matter, is it Spark, is it Python, is it ClickHouse, is it Starox, is it DuckDB, they need just to go and implement that REST specification, then they can go and read the Iceberg table. The additional part on the catalog level is that you can see here in a blue marker that catalog is now responsible to write the metadata JSON file, which means catalog is in charge to make the final commit of your table. So it's how we began. We began to talk about the catalog. This is what we need to build the Lakehouse. And again, it was confusing. Luckily for us, we got additional competency inside of the catalog. That catalog was managing the fine-grained access control. So everything around your role-based access control was centralized in a catalog, because it's the only place where you can manage it. So imagine you have like 5 different query engines, and you need like the only one place where you can tell like, okay, the role reader from my identity provider is allowed to read the table customer. And every query engine will just comply to that because the information is stored in catalog or provided through catalog to the query engines. The interesting part is getting actually today when we talk to customers, because they say, okay, so we built a lakehouse and now we have those three components, storage, we have compute, and in the middle is catalog. And if catalog fails, so no one can actually read and write data anymore, or even interesting situation where everyone can read and write. So the catalog became very critical component, and it's why customers started to call it a control plane. So, and that is the current state. If you look at the every architecture decision, and here's like one of which is a Lakekeeper, but you can replace Lakekeeper, for instance, with Polaris for implementation. You will see that every query engine will go to catalog to understand where's your table, and your table can reside in every of these depicted storages here. Which means if you will talk about the agnostic approach where you don't want to have a lock-in anymore, that's the way how you can actually implement that. So on day one, you need to decide, okay, I'm storing my data in Amazon S3. And then I will use a control plane as Apache Iceberg REST catalog. And I will start with simple Spark. And day after, you will get additional requirements. The first thing what you don't need to do, you don't need to run a migration, because the data is stored as Apache Iceberg, and in that case, it's super easy for you just to pick the next compute engine. Let's say you need a super fast SQL queries, so you can take like Lakehouse, for instance, and then you can run your Lakehouse. And day after, you will get some new departments from your company who uses Snowflake, and you have already 5 years built some business logic in a Snowflake. So you don't need to throw it away. So what you can do, you can just connect your Snowflake to your Apache Iceberg and use it. And that's quite interesting paradigm, because right now, if you will apply that inside of your company, you probably don't need to migrate anymore to any different technology. You can just keep your data as Apache Iceberg and then use all the different storages. You can use all the different compute. The only one central part today is a catalog, but that is going to be different in 2026, where we will get catalog federation. But if you look at the Apache Iceberg, it will probably become similar what you know today as TCP IP protocol, or maybe JDBC, where you don't think much about like how is everything implemented, like that just works. And similar is going to be Apache Iceberg based Lakehouse, where you can just put your information in that universal or open table format and use all the different storages and compute to accomplish your use case. Yeah, maybe just a very quick information about the Lakekeeper itself. It's implemented in Rust. If you love Rust and you love contribute, go to Lakekeeper and contribute. We open to every contribution at the moment, and happy to get any proposals on how to improve Lakekeeper. It's Kubernetes native. It's single binary. Provides UI. We provide Helm chart. You can use it with Docker. It's modular and extendable. You can just go and actually write your own implementation from different traits. For instance, if you have your authorization. And again, we have Apache 2.0 and Enterprise Edition, so it's up to you to decide which way you want to go. But Apache 2.0 is actually very powerful implementation. What I would love to use in the next 5 minutes is to explain you the governance aspect, how you can actually achieve it with Lakehouse, because like in the past you had your single box, you had your Postgres, you had your Oracle, and everything was monolithically stored in that box. And that box secured the access. But if you look at the Lakehouse, as I said, there are at least 3 components, but they're usually way more than 3 components. So everything is distributed and everything is some kind of moving parts. So the access governance is not a trivial thing anymore. So let's assume we have our control plane, we have our object storage, and we implemented our Lakehouse. And we use authorization system. In our case, in the Lakekeeper, we implemented the Google Zanzibar paper based on OpenFGA, the next open source component to manage your role-based access controls. We deployed Lakekeeper on Kubernetes. You can deploy that on your own laptop with Docker Compose, for instance. One important thing, as you can see here, Lakekeeper is not the identity provider. We use the external identity provider, which can be a Keycloak. It can be Okta, Entra-ID, all the different OAuth 2.0 compliant identity provider. And this is very important, that none of components can be an IDP. So none of the components should issue a personal access token or whatever, because that will actually break the whole governance. The only one who can issue the identity and passwords or tokens should be your central IDP. On Iceberg, we actually have two different types of computes. The general one, so that's usually a single technical user that runs some batch jobs, for instance, and writes every hour a data. And then we have a fun part from trusted compute. And this is usually what you see where you have a multi-users. So for instance, it's Trino cluster, and then you have Paul, Anna, Max, and then you want to tell, okay, so we need to distinguish how Paul is going to read the table, and Anna should not be able to read and see the table. But the issue is here that the trusted compute connects to Lakekeeper or to any catalog through a technical user. So which means the technical user can read everything, but how Trino can enforce that Paul is only allowed to read the customer table. So to solve this problem, we have one additional open source component is Open Policy Agent, and there is a contribution to build a bridge between like control plane and trusted computers Trino that will help to enforce exactly this type of information, which means if Paul runs the query, Trino will just analyze who is running the query. Trino will see, oh, it's Paul. Okay, I can pass that query. But if it's run by Anna, it will be blocked. There is a lot of new stuff happening in Apache Iceberg community. There is one additional contribution to Out Manager that actually allows to get rid of Open Policy Agent that situation, and then the whole architecture is going to be leaner. And the final slide or final use case, what I want to talk about is the computational governance. And because Lakekeeper or like any catalog is in that specific place of controlling every transaction, and not just a transaction in terms of select statement or insert statement, but any DDL transaction, if you want to make an altered table, something like that. So let's imagine following situation. We have a data engineer as owner, and that data engineer is in charge of marketing data. So that data engineer creates tables, inserts data in the table, drops tables, alters tables. But we have an analyst from a different department, from sales, who actually relies on that data to build some reports. So what data engineer needs to do? Sometimes change the structure of a table. Like there is a schema change, or even we need to drop the table. We need to get rid of some storages. So then, if that operation is going to be executed, then the report is going to be broken. And that is something what will interrupt the whole business process, which means data engineer who starts at 6:30 in the morning will make the change. The analyst who starts at 9 in the morning will try to execute the report, and that report is going to be broken, and none of the business processes can be actually done. So how can we solve that? So because Lakekeeper is controlling the alter table, so the first check is going to be based on that OpenFGA defined grain access control, and we can be pretty sure, yes, your data engineer owner of that table can operate that. But the second check can be on a data contract engine where we'll put actionable SLOs. So it's not just going to be a simple Wikipedia. It's going to be a really enforceable objectives. For instance, table is undroppable. And in that case, data engineer will get a conflict. So you cannot drop the table. But what you can do, you can go to analyst and churn the contract and give a grace period of next 7 days that there is a new version, or we need to remove that table, or you have a chance to explain me why we should keep the table. So in that construct, you have a preventive mechanism to control the upstream and usage of every data asset, data product, because that's the way how the catalog can actually control and the consumption. And just to finalize the whole thing and just to summarize, so what is agnostic Lakehouse? Well, first of all, it's based on Apache Iceberg, and it gives you always the easy way to exit, where you can just go and then replace every component. The only one thing which like the axiom which stays in that equation is Apache Iceberg, but you can replace storage, you can replace catalog, you can replace compute, you can take best of breed approach. The only one thing is what you need to think about is that the governance should be centralized. So you need to think about how you will centralize the governance, but the computation and storage can be distributed, can be decentralized, can be driven by data domains and so on. We will see more and more on federation side, on catalogs, and we will see more usage on bespoke compute, where we have already a lot of different wonderful compute engines out there, starting from a simple DuckDB to Snowflake in the cloud and ClickHouse that you can run by your own. And I can imagine that tomorrow we'll get even more different computes for different use cases. And especially from perspective of AI use cases, we'll get more and more compute. And therefore, it is very important to stay agnostic, so you're not locked in a technology that will not allow you to go to the next innovation step. And the final thing is quite interesting for us from Lakekeeper. What we see is right now that through the mechanism of data contracts, what I just presented, we can go and build the collaboration data sharing mechanism that you can actually go and more or less build a data marketplace and sell your data if you want to. But you can just trying to improve the whole business process and your efficiency for the data that you can actually get from your partners. So you can think about how to improve the partner network, not just because you have a better negotiation, a price, or you have like a faster delivery, but you have better processes because we are data driven. So that's the whole concept of agnostic Lakehouse, but that's what we built. And I'm strongly recommend you just to keep eye on the Lakehouse on Apache Iceberg. And again, feel free to contribute. As I started with open source, that's the main thing, how we can actually become a very interesting civilization, I would say.